On August 15, 1977, Earth experienced a high-velocity physical trespass. An intense, highly focused radio transmission bypassed our planetary sensors, struck the North American continent, and vanished exactly 72 seconds later. The instrument that caught it was the Ohio State University Radio Observatory, known as Big Ear. This was a 3-acre anomaly trap constructed from flat aluminum reflectors and wire mesh, designed to continuously sweep the sky as the Earth rotated. To process incoming spatial data, the observatory relied on an IBM 1130 computing system. This machine translated radio waves into a continuous stream of printed alphanumeric intensity values on thermal paper. This primitive 1970s hardware, operating on a shoestring budget, captured an event so structurally anomalous that modern astrophysics continues to struggle with the math nearly 50 years later. This schematic illustrates the Big Ear's specific mechanical setup. The telescope utilized a dual feed horn mechanism, essentially 2 ears called the positive and negative horns. Because of their physical spacing, as the Earth rotated, both horns would sweep across the exact same vertical strip of the night sky, separated by a strict 3-minute mechanical delay. At 10:16 p.m., an anomaly arrives. The signal enters the first horn and registers a massive peak, maintaining its intensity across a 72-second observation window. Exactly 3 minutes later, the second horn sweeps the exact same celestial coordinate. The signal is entirely gone. The output drops to 0. This creates a severe problem according to the 5-minute rule in SETI research. SETI, or the Search for Extraterrestrial Intelligence, operates on the principle that a persistent celestial object, like a distant star or a pulsar, must be detected by both horns as the Earth turns. The signal's disappearance before the second horn's arrival excludes fixed celestial bodies. The geometry suggests either an extremely brief microtransient flash or a physical object moving at high speeds. For decades, the data was treated as static. That changed in 2024 with the Arecibo WOW project, a forensic audit that used modern signal analysis techniques to re-examine the raw archival Ohio data logs. This frequency spectrum compares the historical baseline against the 2024 audit's findings. The original assumption placed the signal at 1420.405 MHz. The audit revealed the true frequency was actually 1420.726 MHz, creating a 321 kHz discrepancy. That specific frequency shift is governed by the Doppler effect, a physical principle where waves compress as an object approaches the observer. A massive blue shift like this indicates a staggering radial velocity. The audit calculated the exact speed required to create that compression. The source was inbound at -84 kilometers per second. This inbound velocity places the source on a direct trajectory toward the inner solar system. The official scientific hypothesis relies on 2 components, a cold hydrogen cloud and a magnetar triggering a maser burst. A magnetar is an ultra-dense, highly magnetic neutron star, while a maser is a device that emits microwave radiation instead of visible light. This theory requires a massive cataclysmic energy trigger, specifically a magnetar flare, to force a cold hydrogen cloud to undergo a population inversion and glow brightly enough to match the 1977 data. This chart compares the theoretical trigger against the recorded output. Magnetar flares are chaotic, broadband energy bursts, but the actual 1977 signal was razor-thin, confined within a surgical 10 kHz band. The physics are inconsistent. A chaotic trigger cannot produce this locked, narrowband signal. The properties of the 1977 data match the bandwidth and beaming physics of an interstellar power beam, a high-energy laser array used to provide propulsion to a moving spacecraft. The signature recorded in 1977 matches the razor-thin, high-efficiency exhaust of a directed energy engine accelerating into the dark. The alphanumeric code 6EQUJ5 represents a mathematical footprint rather than a linguistic message. This 3D bar chart maps the IBM 1130's processing cycle. The computer used this alphanumeric scale, digits 1 through 9, then letters A through Z, to track signal-to-noise intensity across 6 discrete 12-second intervals. The peak letter U represents an intensity spike of 30 sigma, or 30 standard deviations above background noise. The 2024 audit revised this to an extreme peak flux density exceeding 250 Janskis. Janskis are the standard unit used to measure the strength of radio wave emissions, and a 250 Jansky reading from a narrowband source is exceptionally powerful. The resulting 72-second curve, a steady rise, a sharp peak, and a symmetrical fall, is the exact mathematical profile of a fixed radio receiver sweeping across a highly focused, intense interstellar power beam. This alphanumeric string is a raw footprint of a colossal energy transfer that briefly washed over our planet. When astronomer Jerry Eman reviewed the data days later, he circled the spike in red ink and wrote "Wow" in the margins. As the exhaust beam of a passing craft, it relied on a singular geometric alignment. The Earth, the beam, and the inbound object aligned for a little over a minute and then drifted apart. Astronomers have aimed increasingly advanced technology at that exact patch of sky in the constellation Sagittarius for nearly half a century. No trace of the signal has ever been found again. The 1977 data remains our only confirmed brush with a technological trespass. This subsequent silence is the most chilling evidence of all.
Every deep dive we take here at the Deep Dive Curiosity Vault is fueled by your curiosity. If this investigation gave you a new perspective today, please hit the like button. It helps our vault reach more explorers like you. Subscribe to join our next mission by clicking the icon on the screen and check out our most recent investigation right here. As we continue to uncover the hidden truths of our world, stay curious.